section of VBT. Now we will see for square planar complexes. Third example, complex Ni Cn4 2-. Once again we will start by writing electronic configuration of nickel. Nickel here is in +2 oxidation state. Cyanide here is -1 charge and 4 cyanide accounting for 4- charge. Overall charge is -2 and hence nickel should be +2. Nickel's atomic number is 28. If we remove 2 electrons, then the number of electrons remaining would be 26. First, let's write argon, which accounts for 18 electrons. 3D. Containing 5 orbitals. 4s. 4s electrons are already lost here. 4p. If required, we can also use 4d. 18 electrons of argon and total electrons are 26. So remaining electrons are 8. According to Hund's rule, first we will fill singly before pairing occurs. So this is electronic configuration of Ni in +2 oxidation state. Let's consider the type of ligand. Cyanide here is a very strong ligand and therefore the electrons are pushed to the left hand side so as to create empty orbitals. So let's write the configuration. Argon 3D now looks like this. We have freed up 1 orbital here. Now 4 cyanide ligands are there. So we require 4 empty orbitals so as to accommodate 4 electron pairs from cyanide. 1, 2, 3 and 4. So 1d, 1 s orbital and 2 p orbitals undergo mixing hybridization so as to result in dsp2 hybridization. After hybridization, the electrons of cyanide ligand fill up these orbitals. We can indicate them as stars or crosses. These are the 4 electron pairs donated by cyanide ligands. So this is the electronic configuration of the complex NiCN4 2-. This was configuration of only nickel metal ion. Hybridization is dsp2. For dsp2 hybridization, we see that the geometry would be square planar. When we have 4 ligands, when the coordination number is 4, there are 2 types of hybridization possible. One is dsp2 hybridization, the other is sp3 hybridization. In dsp2 hybridization, geometry is square planar. In sp3 hybridization, geometry is tetrahedral. Magnetic property depends upon number of unpaired electrons. If we observe the electronic configuration, we can see here that there are no unpaired electrons. As there are no unpaired electrons, there is no magnetic property. That is, the complex is diamagnetic. These points are important, so we should be writing electronic configuration of metal ion, electronic configuration of complex, hybridization, the geometry, and the magnetic property. This is valence bond theory applied to the complex NiCN for 2-, that is a square planar complex.